A very warm welcome. हाइड्रोकार्बन्स के सॉल्यूशंस का डिस्कशन करेंगे, NCERT क्वेश्चंस के सॉल्यूशंस का डिस्कशन करेंगे हम अपने इस सेशन में। तैयार हैं आप? तो चलिए शुरुआत करते हैं। यूटिलिटी क्या है, लेकिन ध्यान रखिएगा हमारे सॉल्यूशंस के डिस्कशन एक एवरेज सॉल्यूशन की तरह नहीं है जिसमें हमने कुछ भी इधर से कॉपी पेस्ट कर दिया है। कोशिश इन सॉल्यूशंस की ये है कि इनके डिस्कशन के माध्यम से थ्योरी भी आपकी पूरी रिवाइज हो जाए और वो जो कॉमन पॉइंट्स हैं कंफ्यूजन के वो भी लगातार आपके क्लियर होते जाएं। एंड दैट इज समथिंग व्हिच इज वेरी वेरी रिमार्केबल अबाउट दीज सॉल्यूशंस, राइट? सो लेट्स बिगिन Unit 13, Hydrocarbons of 11th Standard, NCERT Chemistry. This is Shishir Mittal from Vyas Edification. The first question, how do you account for the formation of ethane during chlorination of methane? Wow. We are conducting a chlorination of methane, then please remember, the first point you mention is that the mechanism. The mechanism is free radical mechanism. So you should first write down that mechanism is free radical mechanism, right? And free radical mechanism takes place in 3 steps. 3. Number first, initiation, when free radicals are generated, maybe by shining light or by heat or whatever mechanism. Sometimes people add catalysts like peroxides, but we manage to generate free radicals as the initiators. Second step is propagation, the most important. In propagation step, something which keeps on happening throughout the main body of the reaction, there are 2 reactions which happen. The first one, when you have methane, it reacts with chlorine free radical. It abstracts, it takes away one hydrogen atom. What happens is CH3H, this H gets connected to Cl. As Cl approaches hydrogen, partially it forms a bond with hydrogen and partially the bond of hydrogen with methane begins to break. And ultimately what happens is hydrogen is taken away by Cl because Cl loves to form a good bond with it, and I'm left with only methyl radical. In the second step, methyl radical again reacts with chlorine to give you CH3Cl and it regenerates. It gives back the original Cl radical, and this Cl radical again goes and hunts up another methane molecule, again eats it away, again generates new methyl radical, and this is the cycle which continues, right? So this Cl can again go back here with another methane, and thousands and hundreds of thousands of molecules are actually converted. Hundreds and thousands of molecules are actually converted before a Cl radical actually gets exhausted or terminated, which is again the third step and the last step of radical mechanism. First and last step are not really the ones which we are concerned with in this question. But the fun part is this. Note that methyl radical is generated in propagation, right? And then what happens? During termination reactions, there is a probability that 2 methyl radicals may just come across each other. 2 methyl radicals may just come across each other, and the moment they face each other, lovingly they can form a bond. All they lack is a simple bond, and this simple, nice, happy bond, the moment this bond is formed, what do you get? You get ethane. That's it, you get ethane like this. And this is how ethane is generated during free radical halogenation or chlorination of methane. By termination involving only methyl radicals, this is what we get. And that is, my dears, the answer to our question. This is the mechanism of formation of ethane during chlorination of methane.